Okay. So today we'll start mainly with scope of variable. So just have a look. I am writing two lines of code. So definition, let's say print file. Okay. I'm not passing anything to this method. What I'm doing, taking one variable num is equals to 100. Okay. I'm trying to print this variable inside a function. Okay, which means I'm defining a variable outside my method and I'm trying to print it inside this method. Most important thing, I need to write my function call. Num is not defined. Right. Okay. Alright, so I defined this variable, print val function call. I printed it here, this prints the value. Okay, which means even if I define a variable outside my function and if I try to access that variable inside this function, this is working. Okay, but how about vice versa? So num2 is equals to 200. Comment this out and print num2. Okay, so now it will say num2 is not defined. Okay, so the concept here is the default scope will be local. Okay, so whatever variable which you are defining inside a function, it will be limited for that function only. Outside a function, I cannot access it. Okay, now fun part. So I'm taking the same variable. So it worked last time. So I defined num1 equals to 100. I gave a function call. Okay, here what I'm doing, okay, just print the same thing again. Now modify the same value inside the function. Num is equals to 400 and print num here again. Okay, so now this will not work. Okay, so now it will say a local variable num reference before assignment. Okay, which means it is saying that I am assigning this variable here, but still I'm trying to refer it here. Okay, but as per my understanding, what I intended to do is I defined a num here. I'm expecting that same value should be printed here, and it worked in the last time, right? But now it is not working. So reason, the default scope will be local. So whenever you define any variable, Python will consider this as a local variable first. Okay. Now whatever num you are defining, whenever you define a num, now it will say, okay, this is a new num variable and assign this value 400. But you are trying to print num here first. Okay, so that is the reason it is throwing you this error. Okay, because it's kind of a conflict situation that which num exactly to use, whether the global one or this one. Okay, so if you want that I am defining a global variable and I want that function to be, that variable to be accessible inside all the methods, then we have something called global. Okay, now this is the keyword global. So now whenever I say global num, that means now it will try to search for this variable outside this function also, and it will take this group. Okay, so now if I print this value, it will consider 100 here. Now whenever I'm modifying the value of num, it will take value 400 num. So the original num which I have defined in a global scope, it will modify the value for that variable and then print num here, and even if after here if I print the num, it will give me 400 value. Okay, so if you want to define a global variable,
100 now, because I mean the last one it should take, after that it's a global, it's accessible after this function also function. So don't you think it should be 100?
So when I say 100, I'm saying this is a global. Okay, that means now there is only one copy of number and it is pointing to 100. Okay, now at this statement I'm saying num is pointing to 400. That means I'm modifying the value. Now we said there is only one copy of num, so when I modify here, I'm actually modifying the global copy also. Okay, so that is the reason when I print it here, it will print 400, and even after going back, it will print 400. Okay, now I'm modifying the global copy. Okay.
Can we do like that global num equal to 400 or something like that?
No. Okay, not at all allowed. Okay, so this is the only one point where you are actually defining something. Okay, so we just started with something called global variable. So whenever I define a new variable inside a function, that will be not accessible for me outside. Okay, so the default scope of any variable is local in Python inside any function. Okay, now if I want that declare a variable outside and I want a modify same value inside a function also, then in that case we have a keyword called global. So what I am doing, I'm just defining as a global num. So now if I say num equal to 100, define it as a global variable. So now if I change its value, it will modify the original copy. Okay, so that's all we discussed now. Okay, so this is one of the important points, that is global variable. All right. So one of the contradictory.
Still, I'm not clear, because the last statement says num is 100. I think 100 should be printed.
Okay, so here how it is working. So I'm saying num is equal to 100.
Okay, it's before print one, that's right.
All right, so this is my function, right? So Python cannot execute this unless and until there is a function call, right? So first statement it will execute will be this, num is equal to 100. So that is the reason it will initialize a value. When I printed the num, it will print 100. So I initialize it to 100, right? Now after that there is a function call. Okay, so how it will work? It will execute this statement. Now function call, go back here, declare this is a global variable, print the value of num. What is the value of num at the moment? 100, print it. Okay, change the value of num to 400. Okay, print the value, printed 400. This is the end of function, come back. Now print. Okay, as this is a global variable, it will maintain the value 400. Okay. All right. Okay, so let's discuss something called.
One question.
Yeah.
Define an entirely new variable within a function, and then we put a print on that variable like outside the function without calling it. Will it work?
So I'm saying num2 is equal to 200, right? You want to print it here.
Yes.
Right? So we tried this. So defaultly the scope will be local. Okay. So that's why this variable is not at all available outside this function. So now if I execute this, it will say num2 is not default. Okay. Oh, it's still cutting something?
Yes.
So you can keep secret certain things here. Like in this way, it's within the function. So it will not be accessible.
Exactly. So that is one of the principles when we go to your object-oriented programming concepts.
What is that? Encapsulation, something like that?
Exactly. So encapsulation, data hiding. Yeah. So recently it happened. Scope of variable. Yeah. So recently we went to Impetus for this Python and machine learning training, and those guys are from core Java background. It was a very good debate about object-oriented programming, because if you see Python's object-oriented programming, it's so much flexible. And if someone coming from hardcore Java background, it's very hard for them to digest the concept of type strictness. that you don't have anything called a data types in Python. It's very hard to digest. It was a very good discussion that how this is a purely object-oriented programming.
So which one is pure? This one or that one?
If you want to take a good advantage of all object-oriented concepts, we will still recommend Java is the best for that. Okay. The reason Python community gives you a lot of flexibility, and it completely depends that you will write your program in a same way, because it will allow you, even you are declaring variables as private, you can access it outside, protected, you can access it outside. So it's completely depend on conventions. So we have standard conventions, like if you are defining a variable with double underscores, you will never try to access it outside the class. So it's kind of an assumed convention. It's not that Python will restrict anything. So these are some of the conventions which entire Python community follows. And in terms of Java, if you talk, Java will not allow you at all. Right? So here comes the difference.
You said the ID, mutability and all that. Say, according to number, and say normally we write in C also A is equal to 5. You write A is 7, that will be raised and that will go to A.
Exactly, at the same memory location it's changing.
But here
it's changing. Here it's separate. It's separate. It's separate.
That is there in also Java.
Same.
So most of the things I think Python they copied from Java only.
No, we can say C.
C.
Okay. Ultimately, it's C only in the background. And this is the very popular use case. I guess I told you that video also, that it's a very good glue language. It is how industry is currently using Python.
Glue means glue language.
It's interfacing language between multiple languages. Now, be it any language, Python will be good for that. Okay, underlying language can be C, can be Java. You want performance, everybody will go for C. No one will go for Java also. This is the still market condition. We know that at what time C is incepted, but still everybody is using C.
But C means those things.
Complicated, yes, but performance-wise, best. Performance-wise, best.
In fact, like in the industry, most of the tools written like on the background, it's just C.
Exactly. And there was one of the folk I gave training to Python. He was working in networking domain and completely in C. So the main job of that person was to find out the memory leakages in C program, and he was very much focused on memory management. Now, if you see Python, it's like it is giving you away the memories. That just define a variable. Let's say if I say A is equals to, okay. If I try to print it, it will not cause me overflow, right? And it's like very hard to digest thing, that how come, because it's going to consume a lot of memory. So memory management thing is, we can say it's not that much optimized. Python tries its best to optimize it, but if you compare it with C and Java, yes, it takes a bit more memory than. So that is the reason few of them consider Python is slower than Java and C, obviously. But it's just the main intention. If you see in Python official website also, the one of the motto they are saying that rapid application development. Be it any problem statement, you can deliver it within 1-2 months of sprints you have. You will deliver at least a good product. Because it will provide lots of flexibility. You don't have to write much lines of code. That's the main advantage, and industry is taking that. And it's like popularity is becoming crazy. Every field it's Python only.
In fact, when people started talking about taking over SAS, Python came in between.
In JSP, we are writing HTML like that. HTML in a Java code. Can we in Python same like that?
Oh yes, you can it is compatible with this. Yes. If you see the compatibility with databases, it's much more easier. So we will discuss how to connect to a database, but we don't have to set up that entire JDBC connection. All these things not required. It's a one-line command, connect to any database. Be it your Mongo, be it your NoSQL, be it your MySQL, SQLite, anything. One line code.
Will you do that here in this Python international?
Yeah. So defaultly it comes with SQLite 3, which is a lighter version of your MySQL. So all the commands which work in SQL exactly the same. So there is just one line command difference in MySQL and USQL. But still you can install your MySQL server also and you can work on it. So we were under impression that R is something getting backseat as compared to Python, but Google is trying to boost R also. So they are trying to launch Python libraries for R libraries for your machine learning. So libraries are not yet stable, but they have released early version of TensorFlow now. So we don't know what's going to be the future of who will prefer what. I am not sure about that. But I'm not sure. But I just got the news that okay, now TensorFlow using R. But you don't know the future how much, because if you see Python using TensorFlow, it's kind of very much stable at the moment, and industry is using it a lot. R is kind of early stages of development. But still, people having R knowledge obviously can take advantage of that. And AWS, what they're doing with their machine learning services is like crazy. I mean, they are trying to pull everything from your Google side to their side, because they are seeing that okay, TensorFlow popularity is increasing and everybody is going for TensorFlow. So now, if you see Amazon's way that okay, everything will be simple, just drag and drop things and we'll get your answer. So same thing they're trying to do with your machine learning services also. So use our infrastructure and do your machine learning on our EC2 instance. So that's what they're eyeing, and they're kind of promoting these things that a lot. They want to get into this field. Azure, where is Azure? We don't know. We don't know. In terms of machine learning, I haven't heard anything. But Google Cloud, I guess I'm getting a lot of ad of start 14 days trial for free for machine learning on your Google Cloud. So they're pushing also. So TensorFlow is ultimately my Google library, which I can use on generally my GPUs. But now they're pushing do everything on the cloud. You don't need GPUs. And the next step, obviously, it's going to be integrating with PySpark.
That's so what you say, like for a data scientist or someone who's pursuing data science, cloud computing is also a part now.
Yes, so before cloud computing, I can say PySpark is the next logical tool. If you have knowledge of data science and machine learning, learn PySpark. Because the next step will be doing all your machine learning on the data.
Which is second you are going for Hadoop.
Yes, kind of replacement, yeah. So Hadoop was popular. So the mainly Spark is my alternative for my map and reduce. It's not the complete alternative for Hadoop. This is the general understanding. But if you say it's not, it's just your alternative for your map and reduce framework. So that's going to be the next logical step. If you have machine learning, apply everything on your PySpark architecture. And that is getting a lot of popularity because in PySpark also they are doing a lot of development. So they are doing a lot of bug fixing and the performance improvement, which was one of the bottlenecks. So one of them was RDD. So earlier in Spark it was doing using RDD, but now they have concept of data frames, so which is same as your scikit-learn data frames. That is the reason now performance is same as your Scala. That's the reason your PySpark is also getting popularity, and every industry is trying for PySpark now. That they are training and staffing everything for PySpark.
Spark is different from PySpark?
So Spark is my big data processing, which is for my alternative for my MapReduce. Now to work with Spark, either you can go with Java, which generally no one prefers. Second is Scala, because your entire Spark is written in Scala. So you have one of the advantage there. And we have Python library also for doing big data processing, which is also gaining a lot of popularity these days.
And what is NoSQL? SQL,
NoSQL, that is also, it's kind of competition you can say between your Mongo and NoSQL. So one of the...
NoSQL, right?
No. Mongo is comes under NoSQL.
It comes under NoSQL.
Because the main concept of your NoSQL is I will not have fixed structures. Okay. So till that point, exactly column-based. There will be no fixed structure, no fixed set of columns, and it is mainly useful for your unstructured data, which generally used for your machine learning purpose. You will not have a fixed update of all the columns. That's something. That's like you have to be updated with these things because things are changing pretty much rapidly. All right, let's come back. So we discussed this. All right, let's discuss something call by value and call by reference. Okay, any idea what is called by value and what is called by reference?
Reference means ID maybe.
Address.
Exactly. So let's say I'm writing one method called print val. Okay, and it takes values like num1 and num2. These are my two variables. Okay, so what I'm doing, I'm just changing these two values. Num1 comma num2 is equal to, let's say, 100 comma 200. And while giving a function call, I am passing values in this print val of, let's say, 50 comma 100. Okay. Now here, if I let's define this two variables separately so that I can print it. Num1 num2 equals 200. I'm passing these two variables num1 and num2. So I'm passing 50 and 100. I'm modifying inside a function. If I print it back here, what will be the answer? Sorry, here I have only one print statement.
Okay, sorry.
So will it be 50 100 or 100 200? Okay. So this is something your call by value, that whatever value you are passing, okay, it will only pass the values. Even if you modify the values, it will not affect your variables. Okay. So this is your concept of your call by value. That means even here, if I print num1 and num2, I'll get the same value. Okay. Now the way we do it for call by reference in your C is we'll pass a pointer here. Okay. So you'll pass a pointer. Now if you modify your value of num1 and num2, and if you print it here, then you'll get 100 and 200. Right. So this is your concept of call by reference. So if I say call by value, I'll not get the updated value. I'll just get the value which I have passed only. But in terms of reference, I'm passing the reference, that means address, and it is modifying at the same address. This is what happens in C or in Java. Okay. So in Python, we cannot say it's completely. So we have seen this example that this is call by value. Looks like call by value, right? I'm passing two values, but still my original values are unaffected. Okay. But if I do like this, so let's say def print val of num1 and num2. Okay. Oh. Let's do this in case of a list. Okay. So here I'm saying L dot append 100. Okay, I'm appending one value to a list. I'm defining this list as a 10, 20, and 30. Okay, let's give a call to this print val function and print the list and pass the list here. Okay, so now I'm passing the list. So in case of an integer, we have seen I passed two values. It went here, I modified them, but when I printed, I got unchanged values, right? But in case of a list, I'll get the changed list. Okay, so it's like in terms of your immutable data types, it is behaving as a call by value, but in case of immutable data types, it is behaving as a call by reference. Okay, so this is the confusion. So if you search on the internet, you will find if you just Google it, what is exactly it's call by value or call by reference. So few of them will give you the reference that okay, pass two integers value, print the value, you will see that it's not affected, so it's a call by value. Few of them will say, okay, pass a list. See, you can see changed value. Because of that, it's called by reference. But actually, it is something called call by object. Okay. Reason, it completely depends on what type of data you're passing. Okay. And everything in Python is actually a class and objects. So that is the reason it is actually called as a call by object. So it completely depends on a data type. So we have seen when I say when I pass this 50 and 100, so we actually, even though we are storing the values, right? So even if I modify the value, it will automatically change the memory location. But in terms of a list, my memory location will remain the same, and that is one of the reason it will retain the so it will modify in the same list. Okay, so that's why we cannot say it's purely called by value or it's purely called by reference. It is actually called by object. Okay. Alright. So let's discuss the case of method overloading. Okay. So Python do not support method overloading. Okay. So why it do not support method overloading? Exactly. Okay. So when we say method overloading, I have two cases. So when I say method overloading, that means I will have two methods. Let's say I'm writing two methods called get. Okay. Now one is I will pass a different type of parameter. So this method has two type of parameter, integer and integer, and this get method has two parameters, string and struct. Okay. Yeah. So this is one of the case of your method overloading, that two functions having same name but different type of parameter. Now if you see the same case in terms of Python, okay, so we
method overloading, it is like
two method having same name but different type of parameters.
so these are our own functions.
Yeah. Okay. So if you see C in Java, it will allow you to define two methods having same function name but difference in parameters. Okay. Now when we say difference in parameters, that difference can be of two types. One, the data type will be different. Okay. So that is the first case. Now let's discuss this case in terms of Python. So when we say get method, in terms of Python, we never specify the data type, right? So we directly just say val1, val2, right? Now while passing the values, either I can pass something like this, 10, 20, I can pass a, b, I can even pass 10, 20, 30, and 100, 200, 300, right? So I do not have any type of type restriction. Okay, so that is the reason Python will not allow you to define two methods with the same name. Okay, because I can get advantage of this because I never specify the type of data. First case. And second case is you might have two methods having different number of parameters. So let's say this is the get method which takes two string parameter, and you might have another get method which takes one integer, one string, and another string parameter. Okay, so this is second case, that two methods having same name but different number of parameters. So here total number of parameters 2, here 3. Okay, but in Python I can write something as get star args. Now this method can accept any number of parameters and any type of parameters. Okay, if you want to make it more generic, I can specify something as args and star keyword args. Right? So that is, so because of these two things, Python will not allow you to define two methods having same name.
Python.
Actually, method overloading and overriding was and is one of the favorite topics in interviews.
So what is the reason
program.
behind that Python doesn't allow? If somebody asks in an interview, what is the reason that Python doesn't allow method overloading?
So if you say the functionality which we intended to do, I mean the main purpose of method overloading generally, if you see in C and Java, type strictness is there. So if I'm defining a method, I need to define what kind of data I am passing, right? So now whenever you're working with your APIs, then you cannot every time guarantee that I will get same type of data only. So that is the reason mainly it allows, okay, define multiple methods. Purpose will be same. It's just the data type is different, right? Now that's what the end goal is. Okay, so to achieve that end goal, Python provides this mechanism. As we don't have anything called type strictness, so I don't need to define two separate methods. I can do this thing only in one method. Okay, so let's discuss recursion in Python. So what is recursion? Okay, so same function calling the same function again. Okay, so one of the best and classical example of explaining recursion is your factorial. Okay, so I'll start with the same example. So I need to write a function which will give me answer of 5 factorial. Okay. Now one way is you can do it using your normal for loop that start from 5, decrement it till 1, and just keep on multiplying 5, 4, 3, 2, 1. Okay. Or another approach is when you say factorial, I can write 5 factorial as 5 into 4 factorial. Right? So same thing I can write it as 4 into 3 factorial. Same I can write it as 3 into 2 factorial. Same I can write it as 2 into 1 factorial, and ultimately my 1 factorial will be 1. Okay. So in short, you are trying to call the factorial function again. Okay. So this is the approach of your recursion. So yes, recursion is faster than your normal function execution, but it will bring the complexity. Okay. So I want to implement such thing. Okay.
So within the definition of the function, you're calling this
the same function. Okay. So I'm taking one number equals to 5. Okay. I'm defining a function as fact, and I'm passing a number. And let's say this will print me the result. So I'm finally writing it into the print statement. Okay. So ultimately, if I say whenever my factorial reaches 1, I want to value 1. Otherwise, I need to decrement the number. So if it's 5, then 5 into number minus 1 factorial. If it's 4, then it will be 4 into 4 minus 1 factorial, something like this, right? So I'm saying like def, let's say fact, I'll pass the number. Okay, so I'll say if num equals 1, then my answer will be 1. So return me 1. Okay, else return num into fact of num minus 1. Okay. So this will print me 150. So how it will execute? Okay. So initially I'm saying fact of 5. Okay. So this is what? This is my function call. So let's write it as, let's say fact of 5. All right. So it will go up. It will check if 5 equal to 1. No. Go to the else block. So in else block I'm saying return. Okay. But before executing return, it will say 5 into fact of 4. Now this fact of 4 is another function call, right? So this will be actually 5 into fact of 4. So once it encounters this fact of 4, before returning, it will actually calculate it will again give a function call. So go to the top with the number 4. Compare 4 equal to 1, no. Go to the else block, calculate 4 into fact of 3. So it will be something 4 into fact of 3. Okay. Again, this is a function call. Go up. It's still not equal to 1. So it will be 3 into fact of 2. Again, this will be 2 into fact of 1. Okay. Now if value is 1, I am saying return 1. Okay. But where it will return? Okay, because I have given now nested function calls. Okay. So keep in mind your function will always return to its caller. Okay. So here I'll get answer as 1. Now I'm saying return this particular answer 1. So where it will return? It will return it to its caller. Who is the caller? This fact of 1. So I'll get answer as 1. Right? So it will calculate 2 into 1. Answer will be 2. Again there is a return statement. So where it will return? It will return it to its caller. So I'll get here answer as 2. Calculate this 6. It will be returned to its caller. So here I'll get answer as 6. So calculate, this will be 24. Return to its caller. Now I will get 24 here. So it will calculate 120 and this will be my final return call. And it will come back here.
Is this a memory intensive process?
Yes. Okay, let's try one more example.
So in general programming, like we use it only when it is actually required, or
it's kind of faster approach to solve the problem. So when we go into dynamic programming and all these things to solve a problem, yes, this is one of the very useful methods. Okay. So let's take an example. So we have seen linear search, that if I need to search for a particular element, then one way is start comparing individual elements. And if I'm searching for 60, the total number of iteration I will need is 6. If I'm searching for 80, the total number of iteration I will need is 80. If I'm say 10, then this will be 1. So average time complexity is your big O of n, right? So it completely depends on total number of elements you have in the list, right? So obviously, if I have 100 elements here, it will take too much time using linear search. So one of an alternative for this is my binary search. Okay. So what is binary search? If you have a list, so first important thing you need is you need a sorted list. Okay. So you can apply your binary search only on your sorted list. Okay. So second thing, you will calculate the mid. Okay. So how many elements I have? 8. So mid will be 4. Right. So fourth element, that is 0, 1, 2, 3, and 4. Okay. So this will be my mid. So that will be, I'll be doing something as length by 2. Okay. So I'll get 4 initially. Let's define our key as 70. Okay. So start from mid. So my mid I'll get answer as 4. Fourth index 0, 1, 2, 3, and 50. Right. So you will directly start comparing with 50. If your 70 is equal to 50 or not. Okay. So we will compare key equal to mid. Okay. If key equal to mid, then you will return true. Okay. If it is not, then you will check if your key is greater than your mid. Okay. So in this case, we have taken key is 70. Okay. So I'll check two conditions: if key is greater than mid or key is less than mid. Okay. As my array is sorted, if I say my key is greater, then even if the key is present, it should be present on the right hand side, right? Logically. If I'm saying it is less, then it should be present on the left hand side. Okay. So what I'll do, if it's greater than your key, I will pass this list which is on the right hand side. That means I will now pass the list as only 60, 70, 80, and my key will be still 70. Okay, if my key is less, then I would have passed 10, 20, 30, and 40. Okay, so in short, now I'm reducing my list to search the elements. Okay, if I get the list, I will again start finding the mid. Right, so now I have 3 elements. Calculate the mid, so it will be 1. So 0, 1, so I'll get 70. So I'll here compare 70, 70, yes, then return true. So let's say we are searching for 80. Okay, now here in this case also it will be false, right? So again I need to check if key is greater than or less than. Here also it is greater than, so next time I will only pass 80. Okay, again find out the mid. I have only one element, find out the mid, I will get answer as 0. Now compare with 80 equal to 80. Yes, then true. Okay, so you can see the process which I am doing, that is if L is greater than mid, I am actually repeating my binary search process which I started from the first. Okay, so that is the reason I can solve this problem using my binary search, the recursion. Okay, what is the end goal? So if key is present, you will always get it as a mid. Okay, now if you compare the total number of iterations, so let's say if you're searching for 80 in linear search, you need 8 iterations. But in this case, for this 50 you take 1, then 72, in a third iteration you got the value.
We are reducing the number of
total number of iterations which we need. Okay. All right. So let's take the same list: 10, 20, 30, 40, 50, 60, 70, and 80. And let's say our key is 80. Okay, I'm writing a function called binary search. Okay, I'm passing this list and I'm passing this key to this function. Okay, all right. So let's define this function: binary search. Yeah, let's take this. Okay, so first thing we discussed is to find out the mid. Okay, so help me to write the code. So how to find mid? Mid is equals to L by 2. Keep in mind your division will be floating division in Python 3.6 version. Okay, exactly. Okay, so I'll use float. So first thing I need to check if key is equals to. Keep in mind mid is now my index. Right? So mid will give me the middle element of this entire list. I want value which is present at that element. If it's equal, let's say return true. Okay, else we need to check these two conditions. So I'm writing elif. First key is, let's say, less than L of mid, and second condition will be, the last condition will, let's keep it else. So if this is the case, I need to do binary search. Okay, so my key is less. That means I need to pass everything on the left hand side. What should I write while writing the call? So I need to pass key as a second parameter. Yes, I need to pass the list which is on the left hand side of mid. Can I write something like this? Okay, I can write mid because my end is not inclusive. Ultimately, we don't need to check mid, right? We have already checked it and it is not true. So that's the reason we are doing this. Okay, and if not, then here I need to do binary search. Yeah, here Hello? The start is always inclusive. Will it do?
Should be like mid, anyways, like the last index is not included, so we can do it from mid only. We do not need to add one.
But if I say mid, it will check 50 again, right? But we have already checked this, right? So that's the reason I'm saying mid plus 1. Okay, to end of the list. Okay, looks good?
Yeah.
Should work? Let's add the print statement. Not working. So we have said that ultimately I will get the element at mid. Right? So the only condition is I need to cut down the list. Ultimately I will get only single element till that point. It's a kind of recursive approach. Okay, so I'm saying 50, it's saying true. Okay, but if I pass anything other than this, it will not work.
Then you can write a print of binary search of where else won't be on the list.
Alright. So just try to debug this, okay? So how many calls you are making? So let's say your key is 80. Okay, or let's say try for 70. Okay. So first call will be your binary search, right? With this entire list and 70. Right? So what will be the mid value? 50. Right? So 50 will not be equal. So you will be making the second call as binary search of, let's say, 60, 70, 80, and with 70 as a key. Right? This will be second call. So in this call it will check with mid, that means 70. Right? If this is case, then it will return true. It will return true to its caller. Okay, it's like this condition. Okay, but if you see that we are not returning this back to its start caller, it's like we are getting the correct answer, but our answer is lost in between calls. Okay, why? Because now if I just write here return okay, why? Because ultimately we are getting answer as true for one of the function call, okay, but we haven't written this return statement, and because of that, if you are making 5 function calls, you are getting a function call answer for the second last, but that true answer is not getting replicated at the top binary search. Okay, so that's the reason your return statements are one of the most important in your recursive approach. Okay, still we haven't handled this condition. And this is strange. Mid is equals to L by 2 L of mid. Are you passing Q? Yes, Q. Okay. So take this condition. Whenever you have 800, okay, so you'll again start from 50, pass all these values, find out the mid. This will be mid, still not present, pass everything which is on the right hand side. So ultimately now you have only one element left. Okay, so if you have a list which contains only 80, find out the mid, What will be the mid? 1 divided 1 floor 2, I'll get answer as 0. That means my mid is 0th element. Compare 80 with 800. Go to the else block. It will check. It is greater than that. So pass everything which is on the right hand side of the list. Okay. But do we have anything on the right hand side? No, right? This is my empty list. Okay. So we can say if the element is not present, ultimately I will get L as an empty list. Right? So I can do something like this. If len of L equals 0, then return false, else do all this stuff. Okay. So now I have handled all the conditions, even if the key is not present. Okay. So this is one of the optimized way of searching any element, and this is using your recursion. Just
So you will not be here on Wednesday and Friday.
yeah.
Okay. So if you have only 3, we can have it for Monday also, not a problem.
You want to come on Wednesday and Friday?
No, this from the Thursday and Friday, I'm not here in Bangalore. That's fine.
So you come from office directly.
No. The person
Yes,
wants
sir.
searching for a job.
Okay.
Inquiries?
I mean, they are everywhere, these kind of algorithms. But so Python, they're
very easy,
much,
right?
But
I mean,
that much new.
I have implemented the same. So in college days, I guess in C and in Java. But when I saw this thing in Python, I was like, oh, it's very easy. Because the main important task is to pass this list, right? The half of the list. So we were writing a separate set of loop to get this much elements in C or in Java, and then pass it to this recursive function. Ultimately, approach is the same, but it's this part is just removing every complexity which you have in binary search. So far we have written everything in one file. So let's say you have functions, you have defined your functions, okay? Now you want to provide abstraction that someone will just provide this list and the key and will get the output. And in the background, it will implement your binary search, right? So just to make it more easier, I'm changing my file name. Okay. So we'll discuss concept of modules in Python. Okay. So in Python, every Python file you write, that is every .py file you're writing, is a module. Okay. So the things which we have seen, that is math, random. Okay. So these are nothing but somewhere they have written a .py file for this. Okay. So to use math, we have said something like import math, that's it. For random, we have seen import random, that's it, right? So same way, if I have this mod1.py, so this is my module, okay? So I'm creating a new file here, let's say mod2.py, okay? So all I need to do is import mod1, okay? So the only thing, all right. So I'm writing here, go back. And so whenever I'm executing this particular mod1.py, it's executing and it's returning me some output, right? Okay. If I go back to my mod2.py, I haven't written a single line. I have just said import mod1. So for mod2, there's nothing written. If I still execute, I will still get this statement. Okay. If I change the output here, save it, go here. Okay. So defaultly, whenever you import any module in Python, as a first step, it will execute the entire module for you. Okay. The reason it does this, because in the backend now it will store the optimized code for this particular module. Okay. So all the functions, if you are saying import entire mod1, it will execute this entire module and it will store optimized code for this. Okay. So that is the reason. If I go back to the directory structure, okay, so it will create a such folder for you. Okay, so I just said import mod1. Okay, so what it will do, it will create this folder __ py cache, and it will store this particular file. So in short, this is my bytecode for my mod1.
Just like in Java.
Exactly. Okay. So in Java you get that .class file, and here you will get this file. Okay. So in the background it's executing everything. Now if you see the use case, so whenever my intention is to import the binary search, I don't want to execute everything and I don't want to see this output, right? Because this is not what I'm intending. So when we say import math, it never shows us any output, right? So if I do this, so I am here import math. Okay, I'll get nothing. Okay, but here I'm getting the output of mod1. Okay, So first step, how to restrict this. Okay, so if I come back to my mod 1, so when we create any Python file, Python is storing some values, built-in values. Okay, so one of them is underscore underscore. Okay, so there is a built-in variable called underscore underscore name underscore underscore. Okay, now wherever you will see this double underscore at the start and double underscore at the end, you are not supposed to modify these values. You are not supposed to give call to such functions. Okay, so everything will be implicit for this. So Python internally storing a particular value. So so it shows me something called main. So what is the meaning of this? That this particular mod 1 is actually executed as a standalone module. Okay, it's not the imported module. So that is the reason it is storing mod 1. Okay, if I go here, now here your main module is mod 2 and your imported module is mod 1. Okay, so on the basis of this, so if I say this binary search is my function definition. So unless and until there is a function called Python cannot execute this, right? So all I need to do is put a restriction on my global scope execution, right? So that I can do using this name variable. So I'm saying if underscore underscore name underscore underscore equals underscore underscore name underscore. Okay, it's just I'm now comparing if the value of name is main or not. Okay, if main, that means this mod 1 is executed as a standalone module. In that case, execute this part. Okay, if it is not a standalone, that means if it's imported module, you don't have to go to inside this if loop and you don't have to execute all these statements. Okay, so now if I execute here, it is working. If I go back here, if I execute this, now I'll not see anything. Okay, so the main reason is if someone execute this as a standalone module, my code should work, right? So one way I can just comment everything this, okay, and go here, execute this, it will not show any output. But in that case, this mod 1 will not be executable module. Okay, so my intention is my both the modules should be executable modules. Okay, but whenever I'm trying to execute this, it should not print me the result of this mod 1. Okay, so that is the reason I'm taking help of built-in values which Python is storing. So one of them is underscore underscore name. Okay, now it's a standard practice that we will check if it's a main module, then only execute the global scope. Otherwise, do not execute this. Okay. So once I have imported this module, all I need to do is define a list. Let's say 100, 200, 300, 400, 500, 600. Define a key. Let's say key is 200, and I can give a call. So as this is defined in this mod 1, then you can say mod 1 dot search of list. Okay. So now it will print me the result. So it will execute it from mod 1 and it will print me the result. Okay. So let's say this particular mod 1 contains multiple files, multiple functions, and you are only working on a one function. So instead of writing this, you can write something as from mod 1 import binary search. Okay, now in that case you don't need to write this mod 1. Okay, so either you can import all the methods or you can import specific methods also. Okay, so when we so now next part is your documentation. So when we have said that import math, right, and when we have typed help of this math, so it shows me the entire documentation of this particular module. Okay, I want the same thing for my module too. Okay, and it's one of the best practices for your Python. So how I can do this? So let's first see what exactly we do have at the moment for our module. Okay, so if I say import of this and say help of mod 1. Okay, so at the moment it's storing a name, say mod 1, and it's defaultly picking something which is written at the top. Okay, scope of variable. Defaultly it is adding all the functions. Okay, so I don't need to add functions manually. Okay, so defaultly it will consider all the functions.
So anyone can get access to this mod 1.
Yes.
So it will be very huge, you know, people will start.
Yeah, so we'll come back to this, how we can upload it and how we can make it our open source. Okay, all right. So for now, I'm just saying this is my binary set. Okay, now how to write a documentation? So we have something called docstring. Okay, so docstring is something which will define the importance of this particular module. Okay, so at the moment it is defaultly considering this value. Okay, so standard way, put a triple quotes at top of the module. Okay, now whatever you will define here is called as your docstring. Okay, so this is actually the module. Okay, so generally what is the main purpose of your module, what kind of functionalities this kind of module will provide, we will add such information in your docstring. So let's say you can add who is the author, then what time it is created, then if someone is modifying it, at what time it is modified. It's kind of proper documentation you can provide. Okay, so now if I save this, if I go here and if I execute this now, so whatever string I have added, now it will add in the description. So all I need to do is put a triple quotes and write a multi-line string. So I can write my entire essay here. So whatever best suits you. Okay. So still I don't have anything for functions. So for functions also you can do the same thing. So go to your module, go to a particular function and just start typing this triple quotes. Okay. So okay, we can specify input is a list and a key, and we can say returns true if key present, else false, something like this. Now I'll save it. So now if I go back and now if I execute this, okay, so this is how I can create my entire documentation for my module. Okay. Alright. Okay. So let's say you have developed something and you want to make it open source and you want to make it available for everyone. Okay. So we have something called PyPy. Okay. So this PyPy site is Python package index. Okay. You can log in here and you can upload your entire package here, so that if someone goes and try to do pip install and your package name, it will be available for that person. Okay. Now for this PyPy, we have some standard set of files to be created. So let's say you have code files with this. Okay. So one important thing is So whatever you are creating is just a module. Okay. So next thing is creating your packages. Okay. So to create a package, all you have to do is inside the main folder in which you are storing your package, create just a file called underscore underscore init underscore underscore .py. Okay, just create an empty file. Okay. Now it will declare that, okay, so the entire folder in which you have created this init file, this is now a Python directory. That's it. Okay, now this is my package. So let's say you have written your mod1.py and mod2.py. So these are your main code files. Then you need to write something called setup.py. Okay. So inside this setup.py, you will declare all the things that, let's say, whatever packages you need for this particular functionality. Okay. Let's say in the background you are using a random module or something, or let's say you are using web scraping module like Beautiful Soup. So it will not come built in. So if I take an example of Beautiful Soup, so someone needs to install that module and then they can take advantage. Now you are directly writing some functions using Beautiful Soup. So you need to declare that dependency. Okay. Now if you declare this dependency here, so this Python package installer automatically first install that dependency and then install your module. Okay. Then you can specify all these details like author, then copyright information. Okay. Then there should be one file called license.txt. So
So you are searching for your first job. How you already got?
Already got, but I didn't go for the
So you are looking in data science.
machine learning data center.
okay, so you will be create one licensing file for this. That okay, so this is your copyright. So all this information will be there in one file called setup.py, and then you can upload this entire folder to this PyPy index. Once this is accepted, anyone, so you can see the packages here. So I was just going through that day and I got that to get the entire data from Amazon website, someone has already created a package. So you don't see, it's kind of API now for you. Open data. So this is keeps on changing. Image library, Python library, automatic input and automatic tools. Oops, I did it went to backside. So it's just new packages got added here and you can search for existing package. So this is the place you can search for if you want to solve any particular problem. So first thing you have to do is search, is there any ready-made package available? Okay. Most of the chances you will get that package there. Okay. So that's all about your functions and modules.
There are written in .py. What is that?
So just to define this as a package, okay, so you don't have to write any command, you don't have to do anything. So just write an init.py, a blank empty py file, that's it. So if you create an init.py file, it will automatically consider the entire folder in which you are storing this file is a Python package. That's it. Now that entire package you can upload it. Yes. Yeah. Okay, so alright. So for next time, we will start with your file operations. Okay, and then next time we will take the execution. Okay.
Now what